Hey guys, welcome back to another Let's Code tutorial. In the last part, we went over if-else statements as well as switch statements, which are basically just a more compact if-else statement. We also went over how these comment things work and some basic operators. In this part, I'd like to go through something called loops. So we're just gonna get rid of all this random nonsense. Wait, did I say loops? I meant arrays. Yes, we're gonna go through arrays. Basically, an array is something like what we did up here, except it's slightly different. For example, let's say you want to record the names of every member in your family. Well, one thing you could do is you could come up with a clever name for each person. So you could have a string mom, dad, brother 1, brother 2, etc., etc. This may work for small sets like a family, but let's say you're managing like a football team with reserve players, coaches. I don't know if they have roadies, but let's say this fictional football team has roadies that we have to keep track of, and there's like 300 people. I'm not going to write string person 1, person 2, person 3, all the way to 300, and then have cin statements for all 300 of them, and then, I don't know, have like a cout statement for all 300 of them. That's just crazy. A much easier thing to do is to make things an array. Arrays are essentially, they're declared exactly the same as any other data type, except with the slight kind of change of having square braces and a number inside. So let's use the family metaphor and say there's 4 people in a family. So this here declares an array where each element in the array called name will be assigned a string value. And since we made this an array, it screws up stuff down here. How arrays work, essentially you start at element 0. So for example, we would have to go like this. Whenever you access something that's stored in an array, you're going to have to give the array name and the position of the data in the array. So let's just make a quick program. Copy, paste, paste, paste. I'm lazy like that. Okay, now then, we have our array with 4 elements starting at 0, because 0 is still a number. So we got 0, 1, 2, 3. Okay. So now, let's get rid of age. And we're going to go, cout. Whose name do you want to hear? Question mark. And we're going to, let's change this up. Int person. There we go. Person. Whose name do you want to hear? So we're going to cin person. Now, forgot the semicolon. Now, unlike before when we just had like name, because that was something, right now name is an entire array, so name is actually 4 names. So what we're going to have to do is we're going to have to define a specific person in this array. So we're going to do these square braces because that is how you do the position. So in the square braces, we're going to write person. And so what's going to happen is we're going to write a name for each element in person, or person in name, and then we're going to ask the user to basically pick one of these numbers, and whichever number we pick, that's the name that's going to get displayed. So we're going to build, one thing you can do in Visual Studios is you can just hit start without debugging, and it will build. If there's problems, it'll tell you. If it doesn't build, it'll just boot up like this. So what is your name? We'll call it Jack. Jill. Red. And Wolf. This is the most awkward family ever. So whose name do we want to hear? So now we've got the option of the person in position 0, 1, or 2. So we're going to hear who's in position 2. Red. So as you can see, Jack is position 0, Jill is position 1, Red is position 2. But what happens when we say something that's 4? What's your name? Jack, Jill, Red, Wolf. Whose name do we want to hear? And I forget myself and punch in 4 because I want to hear Wolf. Oh, what? Oh my. My thing stopped working. Basically, my program crashed. And that's because person 4 does not exist. So I've gone and tried to address something in memory that doesn't exist. It would be like asking someone to look on any map and find Narnia. Narnia doesn't exist, so the person looking for it won't be able to find it and will end up, probably going insane unless they know for a fact that it does not exist. So, using what we learned in the last part, the if-else statements, we're going to punch in a kind of something to make our program more safe. So we're going to write if, and in our brackets, person is greater than 3. So basically, if person is 4 or greater, then it's not going to work. Now here's how you do an OR. So basically, I can do 2 different statements by using these 2 bars. These 2 bars. Okay, I'll just write this last one. Person is less than 0. Okay, so basically, this statement says that we're gonna fix this statement. So let's get rid of this. If the person is greater than 3 or less than 0, then we're going to do whatever comes next. But if I changed this to 2 ampersigns, this means if person is greater than 3 and person is less than 0, which that doesn't work. So, but basically, this is how you do an AND. This is how you do OR. And OR. So a real world example would be, in order to get into Harvard, you have to be really smart and rich. That's probably not how it works in real life. So it's probably more like, in order to get into Harvard, you have to be either really smart or really rich. So that's how that works. But this is not what we want. If So what we're going to want is we're going to have to kind of do the opposite of this. So if person is less than 4 and person is greater than -1. Yeah, that works. Okay. So basically, yeah, if the number is less than 4 but greater than -1, so in other words 0, 1, 2, and 3, we're going to execute this statement. If the number they picked is way off base, then we're not going to run this statement and it's not going to crash. So let's do this. Okay, Jack, Jill, Red, Wolf. So last time I did a 4 and it crashed my program. Let's try this again. This time it didn't crash, it just ran to completion. See, because the end of the program was the next line after that. So everything worked perfectly, it did not crash. Let me just check my time because that went really fast. I think in this section I'm also going to introduce you guys to a new kind of data type. It's called Bool. A Bool data type can only hold 2 pieces of data. The data it can hold is either true or false. Okay? Later on, you can also figure out that it can hold 1 and 0. Basically, 1 is the same as true and 0 is the same as false. But that is what a Bool data type is. And it's what these if statements kind of depend on. So if the statement in here is true, for example, like a 1 would be returned, meaning the statement is true, then it goes in and does whatever's inside. If the statement is false, then it's not just going to jump over. So, for example, let's see here. We'll call this truth. Okay. Now, how are we going to do this? We're just gonna kind of copy and get rid of that. So if all that happens, truth is equal to true. So now we're going to assign the true value, or 1, to truth. Else, truth is equal to false. So basically, as long as the person stays within the parameters, it will be true. If they don't, it'll be false. So now what we're going to do down here is create one more if statement. So if truth. And now the reason we can do that, Control V. Now the reason this works as opposed to if person is that, well, you're probably going to get an error one way or another with this, even if it's not saying it right now, is the fact that an integer is not a statement. So an if statement is looking for something that it can say, this is true, this is false. So if someone just says, this is true to you, that statement, this is true, is probably true. If someone says, this is false, we can take that as being false in real life. So we can do that the same here and now. So truth. So we're going to compile all of this. Okay. Jack, Jill, Red, and Wolf. 3. Wolf is a good name. Yay! I'm going to show you one more feature just so that we can kind of, see it step by step. So we're going to actually hit the Start Debugging. If you're going to follow along, make sure you press on the sidebar here to make that red dot, because this is very important. Come back. Basically, this is a breakpoint, so the program just stopped here. And so what we're going to do is we're going to let's just minimize this. So, what the program did is it created all these values. And so now we're going to, it's this one. There, yeah. We executed this statement. So now the pointer is looking at this thing. So we push this again. And now we're looking for input. So we're going to go Jack, enter. And now the pointer's here. Oh, we gotta push this. Jill, enter. Pointer's moved. Red, oops. Oops. Yeah, you actually have to push this button. Red. And push it again. Wolf. Enter. So now we followed the pointer. We've gone through each of these steps. So now we're going to hit that again. Whose name do you want to hear? And now we're going to see in a number. Let's put 6, just because we're rebels. So now the pointer's at the if statement. And we're going to do that. You should see it jump now from the if to the else. Well, it jumped to the else and then went right in. Okay, so now we're just going to do that. And now we're at truth. So now if you hover your mouse over truth, you can see that truth is equal to false. Actually, in this state, you can see pretty much what every value has. So I can hover it over person, which has the value 6. Yeah, person is 6. Name, as you can see, Jack, Jill, Red, Wolf. If it had more people, then there'd be obviously more names in there. So yeah, this is kind of a cool thing. It helps with debugging larger projects because you can kind of stop and just check what's in everything. You don't have to use cout statements everywhere, but you can, and I have in the past. It works. So now this if statement, truth is false, so we should just jump over. And we did. And so now return 0 ends the program, and we're done. Oops. Just don't pay attention to this. That was the program. And it's not stopping, so we just hit this stop debugging. And that's the bool data type. That's essentially how arrays work. In our next part, we're going to definitely look at these two data types even more, because in the next part, we're going to be looking through loops, which are incredibly important in C++. And general programming, loops are important. But I'll do all that next time. Until then, I'll be seeing you.